And in this episode, we are going to build a series parallel circuit, something like you might see in Chapter 7, and see if we can't build a circuit and then make each branch measurement individually. Okay, so I'm going to show you how that's done in my process if I were going to start this Chapter 7 lab. So I've got sort of everything laid out here that I'm going to use. I've got 3 resistors. 2 of those are going to be in parallel. 1 of them is going to be in series. Okay. Now, in my parallel builds, I typically will put in a few extra wires, and that's why I've got some of these shorter ones here. You don't want really, really long ones like this one back here. The shorter, the better, right? But don't make it too short to where you're crimping the wire or putting a 90 degree on the wire, okay? So anyway, when I do a parallel, right, so I use a few extra pieces of wire. I'm going to do the same thing on this one and show you how to make it easier on yourself. You don't have to put this many wires in there. And in fact, you should always try to use as few wires as possible. That's why when you see a PCB board, there are typically no wire connections at all. Everything is soldered in with copper traces. So, but when I'm making a measurement like this, I want it to be as easy and straightforward as possible. So the first thing I'm going to do is I'm going to take my meter, I'm going to turn it on, and I'm going to measure all 3 of these resistors. Now, these may not be the same 3 resistors in your lab that you are supposed to do, but it doesn't matter because the process is what you're trying to figure out here, okay? So the other thing I like to do, because I'm working by myself and I don't really have a third hand to hold things down, I use other measures, and that's why you kind of see a mess of wires here. So over here, I rubber band together my leads on my DMM, okay? And what I do is I put clips like this, okay, on each one, alligator clips. And that way, you know, it's just easier if I can clip onto something because, like I said, I don't have a third hand. I don't have a partner that I'm working with. I'm working alone, okay? So, you know, go ahead and clip those on to the ends of your leads. And if you want to take it a step further, which I typically do, I'll even put a piece of wire on here. That way I don't even have to clip on to anything on the board. I just put the wire in the hole in the same group of 5 or, you know, wherever to make a measurement. So I'm going to do the same thing with the red one here. So just to sort of recap, I bundle the leads together right out of the DMM. I put alligator clips on the ends of the leads. And then I put a piece of wire on the alligator clip so that I can easily put that into the circuit. Because if I didn't have, or if I was with another person, then I would just use the leads. Okay, I wouldn't bother with all this. But this makes it easier if you don't have a third hand. Okay, so I got my meter ready to go. First thing I'm going to do is measure ohms. So obviously I need to make sure that my leads are in the right place and then I'm in the right range. Some of you may have an auto, and so you just want to put yours into the ohm range, okay, to make a resistance measurement. So just like in the other video, I'm going to measure all 3 of these. Okay. So here's the first one. And actually, before I put these in, I'm just gonna use the alligator clips themselves. So I can just clip onto either side of this. Now, I try to use my thumb and my forefinger here to hold the body of it so that I try not to touch the wire at all, okay? And then there's the other side. And my meter is reading 6.76 kilo ohms, okay? So that's actually a 6.9, so it's a little bit off, but I believe it's still within tolerance. Here's the next one. Either side, hold the body with my thumb and my forefinger, and it's measuring 3.25 kilo ohms. And I believe this was supposed to be a maybe a 3.3. Yeah, 3.3. Okay. So that one's definitely within tolerance. And then my final one, this third one here, oh, it's out of range. I'm going to go down. Oh, I'm sorry, up. So it's measuring, this is my 3.9K. So this is 3.84. I think that's within tolerance as well. Here's the thing. They don't have to be in tolerance for what we're doing, okay? So anyway, got that one squared away. Now I'm going to put these leads back on my probes so they're ready to go. Okay. Actually, not the leads on the probes, right? But rather the alligator clips. All right. So what I'm going to do is, if we kind of look at what the lab is, that this is in reference to, you can see there that it goes into a 1.5K and then it branches out to a 3.9 and a 6.8. Okay. So I'm going to do the same type of shape where I have the series resistor in series with the source and then the two resistors in parallel that branch off from there. Okay. So on my breadboard, as far as the power is concerned, I do something similar. Okay. The little 9-volt adapter that they send with the kit is great because it allows us to use a 9-volt battery and gives us a bigger charge. But the little tiny, the wire that comes with it is very, very flimsy. And not only that, it's not solid core, it's threaded, okay? Or twisted. And so what I do is I put alligator clips on the battery itself, and then the same thing. I connect it to the board with alligator clips to these two pieces of wire. Okay, now I don't have one of them on there because I don't want to connect the circuit and drain the battery until I'm ready to make a measurement. Okay, so now I'm going to set this up. And I'm going to put, let's see here, what do I have? I've got a 3 point, that's a 3.9. I've got a 6.8 and a 3.3. So I'm going to put the 3.3. And I'm going to build this just like you saw in the previous Word document there, okay? So here's I'm going to zoom in as much as I can here. Okay, so there's the first one. Now, I'm going to take a small wire and connect to that same group of 5, and then just put it over here. It doesn't really matter where it goes, but I'm just going to put it over here, okay? Trying to get a good focus there. All right. And then I'm going to, from this terminal here, okay, I'm going to branch off. And I'm going to have one wire going to here. And it looks like I'm going to need to cut a piece of wire real quick. Okay. So from that one, this is my, this is the 3.9. So I'm going to connect to this spot here and then just bring it to the other side. Okay? So there's my show you this connection here. There we go. Okay, so I've just daisy chained out at least this one right here. Okay, now I'm going to do the same thing with the other resistor. Okay, I'm going to, just so I can see it for clarity, I'm going to bring it off to the side. So again, I'm putting this in the same place, but now I want to go find a different group of 5. It doesn't matter where it is. Over there is fine. But just so it's distinct that we are connecting 2 different circuit paths for the current to flow. And I'll do a close-up when I'm done with this. So if you're having trouble seeing, just hang tight. Okay. So there we go. All right. So that's my first resistor. I just have a little jumper to go over to that next point, and then I have 2 branches that come down, and now I'm going to complete the circuit on the bottom. Okay. Now, it doesn't matter where you go. I'm using this entire, I'm actually going to go this way. I'm using this entire bottom blue rail as the ground. Okay, so you can see here, if I push this over, that the black lead from my 9-volt battery is going to go on the blue. And remember, that whole blue strip is all wired together underneath. So I'm just going to go from this resistor to this. Well, there we go. So just right there, and then I'm going to do the same thing with this other one. And just kind of spread them out. Okay. All right, so we have a complete circuit here. So let's take a closer look. A little bit of a focused. Oh, battery glitch. Okay, so here we go. Got again the 3.3K jumper over to this next spot, and then what's really hard to do. And then we've got the 2 parallel branches that come off that one point. They both are connected to the blue, and that's connected to the negative terminal of the battery. Okay? Okay. So now I'm going to pull back so I can see the meter. So now you can see where everything is. Okay. I'll pull that meter into shot. Okay. So I'm going to go ahead and connect this, and so it's going to start draining the battery now. Okay. Now, I could have come from this terminal here up to the red, but I don't need to do that for this. So I'm just going to go plug in right into the first resistor here. Okay. So right now it is under load, and if I wanted to make a voltage measurement, I can do that. So I'm going to go switch over to DC volts, and I'm going to measure the voltage at each point. Okay. I'm leaving this in the 20-volt range. I may need to go down to the 2-volt range, depending on what the voltages are. Okay. Now, if you've watched the lecture video on series and parallel, which I hope you have, or a lot of this stuff isn't going to make sense, you know that no matter what, since those two are in parallel, the last 2 resistors there, those should have the same voltage drop. Okay. So we're going to verify that real quick. We're going to make a voltage measurement. And I'm just going to put these 2 pieces of wire in here and in here in this group of 5. And so that's the measurement. So we got 2.75 volts over. Let me use a pencil here or something to point. Okay, that's on this resistor right here. Okay, this one with the black lead here. Okay, now I'm going to move it over to the one on the right. Same thing. I'm going to put the 2 leads on the same 2 groups of 5 there that the resistor is held in. Now for this second one over here, I'm getting 2.75 volts, okay, which is, I expect that. They're 2 different values, but they're in parallel. So it doesn't matter if it's in parallel in a series parallel circuit or just a parallel. If resistors are in parallel or branches are in parallel, they are always going to drop the same amount of voltage no matter what, okay? Okay, so there's those 2 voltages. Now I want to measure the voltage across that top resistor. So just like if I was going to put the leads on there, I'm going to put my positive lead here, and I'm going to put my negative lead on the other side of that resistor. Okay, so if I zoom in here, you can see. Okay, so I've got my lead on one side and the other side of that top resistor. And this one's a little bit different, so let's see what the meter reads. This one is 3.64 volts. Okay, so this one drops the most, and then this drops the rest of it. Okay, now all together there, we're talking like 7. Okay, we're talking like 7 volts total from the battery. Now, this is a battery I used all last semester and a little bit over the summer. So it is well down below the typical 9 volts that you would see. Okay, and remember, if you've seen my other videos, if the resistors in the circuit, if the total resistance is not sufficiently high enough, you are going to end up drawing, you're going to have less total voltage available because you're going to hit that internal series resistance and it's going to drop voltage there. So you're going to lose, the more current you try to draw, the more that internal series resistance is going to drop voltage, right? And it'll reduce the amount of total voltage that battery can supply. So right now we're down in the very, very low kilo ohm range. If I increased the resistance of all these resistors up into the like 50K range, or even like 100K, then this battery should be closer to its actual value. But under load, it's always going to be a little bit different than what it is when it's at rest, because of that internal series resistance. Okay, so there it is. Those are my 3 voltages. Now I want to make a current measurement for all of them. So my total current that I'm going to measure, you can measure it in a couple different places, and I'm going to show you how to do that. Okay, so I'm going to take this down to 20 milliamps. The other thing I'm going to do is I'm going to go ahead and pull these leads out. Okay, I'm going to move my DMM lead over to milliamps so I can make a current measurement. And here we go. Now, if I'm going to make a, see if we can go ahead and zoom in on this. If I'm going to make a total current measurement, which by the way is also going to be the same current as any resistor that's in series with the source. And so that's this one right here. Okay, it's in series with the source. There's no parallel branches. The total current will equal the current through that resistor. So that means I can measure my current here at this point and break the circuit, or I can break it right here, or for that matter, I could break it right here. Okay, I don't want to go beyond that though, because then I'm getting into the individual branches. Okay, the other place I could make the measurement is right here. I could put it in between the negative lead of the DMM, or I'm sorry, the battery, and then the bottom rail here. Okay, that will measure the total circuit current as well. I'm just going to break it right here. Okay, and instead of clipping onto it, because I've got the wires, I'm just going to stick this in a different spot. And so now I'm going to put the ammeter in between here. So my positive lead comes over here. My negative lead on the same group of 5 on that line. Turn this back on. And I'm measuring 1 point, well, you can't see that, but let's see here. So 1.11 milliamps. Okay. All right, so that is the total circuit current. Okay, so let's go ahead and do each individual branch current. Okay, so I'm going to go ahead and pull this out. I'm going to reconnect this where it was. Okay, now the whole reason I did this was to make this so much easier to measure the current. Okay, what I'm going to do is I'm going to take this out. Just take it out all together. I'm going to put my red lead in that same group of 5 where one side of it was. So you can see right there, I made the connection. And then I'm going to put the other connection on the lead here. So right there. Now I'm measuring the individual branch current. And something does not want to stay connected here. Let me try to figure this out. Okay, there we go. So now with this meter, it doesn't have a microamp range, and so when you see a 0.71 milliamp, just convert it over to microamps, which means this is drawing 710 microamps to this first branch. Okay, so 710 micro. I'm going to go ahead and take these out. I'm going to put this right back where it was, so I have a completed circuit. And now this time I'm going to take out the black jumper wire and just put my meter right in between. So again, I really could have left my red lead where it was because it's going to be in the same spot. But now my black lead is on the terminal with the actual resistor. Okay, now you can see that one is drawing 0.4 milliamps or 400 microamps. Okay, which is good because the 710 and the 400 add up to 1.1, which was our original total current, right? So the total current has to equal the sum of the individual branches, right? KCL is what is governing this. So we have this current that comes from the source, and it comes through here, 1.1 milliamps. It hits that, it hits this junction right here. 710 of that 1.1 milliamps, 710 micro goes through the first resistor, which is my 3.9. Okay, and then the rest of it, the 400 micro, goes through the 6.8. Okay, so I would expect that, you know, when you have these two in parallel, obviously the one that's got the smaller resistance is going to have the higher current because of Ohm's law. So I would expect that this 3.9 is going to have a higher current than the 6.8. Okay, so again, the total current goes through it. We could have 6 resistors in series before we hit that first parallel junction. Okay, all right, well, so those are all the measurements that you're going to need to make. Once you have made these measurements, then you can calculate any powers that you need or whatever. Okay, so hopefully this helps.